In this video, we're going to talk about coordinate systems and homing. Coordinate systems is probably the #1 support question from new people getting into the CNC hobby, or for people starting up with a controller their first time. There are two coordinate systems you need to be concerned with. The first is this button, machine coordinates. When the red LED is lit, you are showing what the machine thinks is the distance from the home switches. You'll notice mine says 0, which means my machine thinks it's sitting right beside the home switches. If I turn it off, I'm at the work offset. Work offsets are also referred to as G54, G55, G56, G57, 8, and 9. G59 has a further parameter call which can turn on any of another 254 offset systems. You have a grand total of 254 offsets in the system. But for most users, you're going to be concerned with 2 only at first. As you get more advanced, you could look at the 3rd and maybe a 4th and a 5th. I doubt that most would go beyond 5. However, you do have immediate access in the program with a button to select up to 6 of them. So, first thing to be considered when we talk about machine coordinates is what do they mean in relation to your table? Well, we have a button here called Display Mode, which will switch me to look at my table. You'll notice when I pushed it, I now have a large red box, which is no longer displaying the outline of my program extremes. It's showing my table extremes. My table is programmed in the program right now to be 100 millimeters wide and 100 millimeters in the Y. So this is showing me a distance of 100 millimeters across the X and 100 millimeters across the Y. That, incidentally, is programmed in the homing and limits configuration right here as my soft minimum and soft maximum. You'll see my X is programmed to 100 as its maximum, 0 as its minimum, 100 and 0 for the Y, and you'll see the Z is a little different. Its maximum is 0. Its minimum is minus 200. This is because the Z on this theoretical machine has a 200 millimeter movement starting at the top. Most people home their Z to the top. This is not true of plasma users, but for everyone else, it's very typical to home the Z at the top of its run, which becomes machine coordinate 0, because 0 in machine coordinates means next to the home switch. So make sure that when you're setting up your soft limits that you set a maximum of 0 for Z and minus 200 or whatever your throw is for your Z. Typically, your minimum in the Z is your full stroke movement in the minus direction. So I have set those soft limit minimums and maximums. So my system, when I hit display mode, will toggle from showing me the job with the red box showing the minimums and maximums of the G code that's currently loaded to showing me my mill, where my item is sitting on the mill, and my job. You can see if I zoom in on this that there's my G code Roadrunner, and it's sitting very small near the center of or very close to the home switches on my table. Most people would not want to cut a job at that position, however. They would want to cut a job maybe by throwing the material into the center of their mill's table. Because of that, we need another coordinate system. The machine coordinate system is not going to do it. The machine coordinate system simply cares about 2 things. Where is the home switch? Here in this position in the bottom left-hand corner. And what is the size of your table? These are the things that the machine coordinate system takes care of. They're very important that they never get changed, so there is only one way to change machine 0, and that is by homing. Referencing your system to the home switch is the only thing which will change the machine coordinates. So let's take a look at our secondary system by turning this off. We're still on a toolpath display showing my entire mill. If we were to jog, you can now see me jogging across my mill table. Now, by zeroing at a particular spot, by pressing the 0 buttons, and then regenning the toolpath, you'll see my crosshairs are showing 0 position is right where my Roadrunner is now located, off center from the home switches and where I placed it on the mill. This is a very typical way of cutting. You put a piece of material on your mill table, you jog until your tool actually touches your piece of material, you jog your Z down so it touches the material, and then you 0 all of the items. You are then, when you regenerate the tool path, you'll notice my tool path is now further onto my table, and I'm zeroed right at the start point or the origin of that piece. By hitting the machine coordinates button, we see some numbers appear. These numbers are the distance from the home switches. So in this case, my Z is 7 millimeters down from its top of stroke and touching the piece. My X and Y is 39 and 41 millimeters from here to here. Normally, you'll only look at machine coordinates if you're trying to figure out where you went wrong. Normally, that LED is off because you know you want to be at 0, 0 when you're at the left-hand corner of your material. If I switch my display mode to job control, you can now see my crosshairs are at 0 and I'm ready to cut my piece. Most people will leave their display in this position. Now, all that having been said, let's take a look at reference switches and homing. I'm going to switch back to table display so that we can see the entire table and see what's happening. I'm also going to make sure that I have my home switches turned on. Under Input Signals, we have an X home switch set for port 1, pin 10, and a Y home switch for port 1, pin 11. Mine are set for active high because that's the way I have my switches set. Yours would normally be set for active high as well if you're using a safe method of connecting your switches. Active low would mean that when your switch gets hit, it grounds the wire. Thus, active when it goes low. That is a possible way to run. It's safer to go with active high, which means that the switch is always connecting the wire to ground except when the table hits it. That is an active high signal. It's safer because if one of those wires should break, you'll immediately have a problem. It's best to find those kind of problems immediately rather than waiting until a home switch just doesn't work and an axis slams into an end stop. Active high is the safest setting for a limit switch or for a home switch. So we've got them turned on. We're going to hit OK. We've reconfigured so we have an e-stop, so we reset the system. Now we're going to do a reference all. Before I do a reference all, though, and before any of you do a reference all, go to your diagnostics page and hit your home switches. Your screen should look like this with none of them lit at the moment until you push a home switch, and you can see mine just came on. I release it and it goes out. Same thing with the X. M1 is motor 1, motor 2, motor 3, etc. So that is the X1 that is flashing here now, and the Y, which is flashing here. Now that we've confirmed that the switches work, that when they're pressed, they light up, we're free to try a reference. So let's hit reference all. You can see that something is wrong. My Y-axis is now moving in the plus direction. That is not proper. You should always home to the negative direction. So we're going to stop the movement by hitting the escape key in this case, and now it switches over to reference the X. And again, the X is wrong. It's moving in the positive direction. So I'm going to hit the escape key to stop that movement. Now we have to correct it. We know that both axes are moving in the wrong direction to home. So if we go to Configure, Homing and Limits, we can see that there is a checkbox for home in the negative direction. Most people would have this checked for X and Y axes, but not for the Z axis. A Z axis usually homes positive direction to the top of the column and stops. So this would be the normal connection. And we'll hit OK. Now if we hit Reference All, we can see the Y-axis is moving in a negative direction towards its home switch, which is down here somewhere. And when it hits the switch, it's going to stop movement, reverse direction, and move until it moves slowly until it comes off of the switch. When the switch opens back up again, the system will take that as its home position. So we'll just wait for it to get down to the 0 position. It's safer to hit your switch slowly and more accurate as well. Now we're going to hit our switch. The switch went active. We changed directions and it just moved off the switch. When that occurs, the x-axis begins its movement towards its home switch. Now I have a simulated table here, so I'm free to press the home switch whenever I like. So I'm going to press the home switch now. The axis reverses direction and the home switch releases, and we're now homed. And you'll notice that the lights are green. Green means that you have successfully homed the control. Hitting Regen Toolpath will show the toolpath at its new location because the home has changed. And it shows our crosshair is away from 0. This is because our work offset system was not zeroed. Only the machine coordinates were zeroed. And if we look, we can see that they actually did not zero. This is again my fault in a misconfiguration. And if we look at Configure, Homing and Limits, you'll see there is an auto zero checkpoint. These, for most users, should be checked for all axes that you're using. This will zero the coordinates of the machine coordinates and stop you from getting confused about how to zero. So we say OK to that, and let's re-zero our system. The Y begins to go to the switch, comes off of it and stops. The X goes to its switch, and when it hits it, it reverses direction and stops. And you'll notice it instantly flicked back to 0. Our system is now 0 in machine coordinates. If I regenerate the toolpath, here we are zeroed again. Now we have our secondary system. Let's say we jog away from zeros. We've got a piece of material on our table, so we're going to jog up to it. We're going to move our Z down. Now we're touching our material, which is out here somewhere, and we now zero our axes. When I switch to machine coordinates, you can see that we have a display showing how far away from the home switches we actually are. But if we turn off machine coordinates, we see the result of our G54 offset system has zeroed us. If we regenerate the toolpath, which you must do after playing with referencing and zeroing, you can now see our Roadrunner is going to be cut somewhere in this area of our mill table at a 0 coordinate on our G54 system and at coordinates 32, 37, 16 in our machine coordinate system. Now I can switch with the display mode button to go back to show us our work coordinate system only. So the red box now indicates the size of our drawing and not the size of our table. So we're cutting it there, and this is what we're cutting. Now you'll notice that even though I said ref all, I have a green light on my Z. This is because I have not programmed a home switch for Z. If you don't have a home switch programmed into your system, pressing ref all will reference where it is at any axis without a home switch. This means that the machine coordinates for that axis will immediately go to 0 if you have auto 0 selected, and you won't move. For people without home switches, they almost never have to push the 0 buttons unless they just want to zero one axis. Pressing ref all will zero their axes on the spot. So, if we jog to a new location and we say this is actually where we want to cut our piece, we can do so just by zeroing the axes and hitting regen, and there we are. You'll notice it looks the same as before we hit regen, but there's an important difference. If we look at our table control, it has now moved slightly to the right and slightly upwards. The system, to cut safely, should always know where you're cutting, what you're cutting. So sometimes it's a good idea to take a look at your display mode and make sure that that square, the job that you're cutting, actually looks like it is in that location on your table. Again, to get this screen to be accurate and to display this way, make sure that your soft limits are set properly, that you have homed your system, and after changing any soft limit settings, restart the software. If you don't, this display will not work properly. It needs to start up the program with valid soft limits. you'll see the soft limits light here is on. You don't have to use soft limit safeties. I like to. If I was at this point to jog, because the system knows where my home switches are, if I was to jog towards a home switch, my axes will slow down as I approach 0. And you can see that the system just stopped, telling me that the movement was aborted because I hit the 0 point. If I look at my machine coordinates, I jogged it to 0. But the system will not let me jog past 0. It just simply stops me. That stopping is automatic and works on all all axes that have a soft limit enabled. And as long as your soft limits are hooked up properly, you'll know it by being able to select your display mode button. Otherwise, your display mode button will show you a nonsense image, which really doesn't mean much. So let's look at what other fixture offsets could be used for. If you look at your offsets table, you can see the current work offset is G54. This is normal at startup and will always be G54 unless you specify a different fixture offset. Let's say, for example, that you wanted to put something into the G55 offset. There is a work offset table here. And if we go to G55, let's, for the heck of it, type 5050 and 0 in the Z and save that. You'll notice that now my G55 shows what I've got entered in the table, 50, 50, and 0. We're not going to use it yet, however. We're going to go back to our G54, which we have used for jogging about and zeroing the system to our table at this position currently, because I just re-zeroed at a different location. We just moved our job again. But let's say that you always wanted to cut this Roadrunner at 50-50 on your table because you have maybe a jig here which holds your board securely. To do that would be pretty easy. All we'd have to do is home our system so that we know that we're accurately at home. And again, I'm going to cheat this system by telling it, there we've hit our switch, and now the X has hit its switch, and now everything is zeroed. I'm going to regen this, and you can see that our machine coordinates are 0 because we've homed, but our Roadrunner is being cut up here. But our jig is at 50-50. That's no problem. We can go to the offsets page, say that we wish to use our G55 offsets, which we have permanently stored 50-50. We go back to Program Run, and we say Regenerate the toolpath. Our Roadrunner has just appeared at that 50-50 jig. Now, as long as you never press the 0 buttons while in this G55 offset system, you'll know it will never change. Therefore, anytime you start your table, you could home your system. It'll go to its switches. You then go to Offsets and select G55. You go to Program Run and say Regenerate, and your job will always appear right on top of that fixture. You're ready to cut any time, and you'll notice we say -50 and -50 on our DROs. That's telling us that currently this job which is being displayed is 50 away from our home switches. So we're free to start cutting even though we're currently at 0-0, so we're currently here, but because we selected our G55 system, which has a 50 offset, the system already knows that I don't need to zero to the corner of this board. It already knows where it is. So if I were to hit cycle start at this point, the system could move and cut that piece. You'll notice we just got an error, soft limit system, movement aborted. Well, if we look at the G code, it's telling the Z to go to plus 0.2. Well, right now our machine coordinate Z is 0, as well as our work offset system. So Z cannot move to plus 2. We've told the soft limit system Z will never go above machine coordinate 0, which is its home switch. So the reason we got this error is that when we set our offsets, we set a 0 in the Z. And when you set a fixture offset, because you have a jig attached to your table, you're also going to know the height of your material, so you would have set a value in here telling the system how far down to move the Z. So let's move the Z down to minus 20. So now, in terms of machine coordinates, and you always look at your settings of these fixtures in terms of machine coordinates, we are 50 away from the home switch in the X, 50 in the Y, and 20 down in the Z from the home switch to this particular jig that you have on the table. And whenever you change something like this, you can see that it just appeared in my work offsets table, but I have to select this to save it to be safe. So now if I regenerate my toolpath, nothing changes. We're still at the same location, but you'll notice that my Z now says that I'm at plus 20, but I'm at 0 in my machine coordinates. Let's reference everything so that we're starting fresh, because I'm sure at this point you may be getting a little bit confused. We're going to 0 our Y, 0 our X, and our Z automatically zeros because we don't have a home switch hooked up. This means that now, in relation to our fixture that we have set, we're 50 away from home, 50 away from home, and 20 higher than what we need to be. So when it hits the first line of G code telling it goes 0, 0, and 0.2, it's going to go down to the proper level. So let's rewind this file, and let's see what happens when we tell it to start. As you can see, the Z is now moving down to get to the top of the material, and now the job cuts normally, even though it started from the home switch. So that's what an offset system is handy for. You can program different fixtures on your table which hold material, program them for the absolute coordinates. The only rule to remember is, once selecting offsets 2 and onward, do not push the 0 button or you invalidate those offsets, because pressing the 0 button changes whichever fixture offset is in effect. When you start the system, you're in G54. So let's stop this job. I'll show you you cannot change the display mode while a job is running, so you can't really see what's going on here. So let's stop it, rewind the program, regenerate the toolpath, flick to the display. Now we can see that it had cut a little bit of this Roadrunner when we stopped it. But let's take a look at what happens when we press 0 on something. Let's go to our offsets page and select G54, because again, we don't want to affect what we have entered for this fixture. So whenever we're going to play around with zeroing, let's use G54 for now. Our G54 offset currently is 15.9, 58, and minus 16. If I jog to a position on the screen and zero my controls and go back to the offsets page, you'll find that these numbers have changed. We're now 56, 56, and minus 20. That's because what you store in a fixture offset is always the distance from your home switches. That's what all of these fixture offsets are, is distance from home switches. So in G54, the distance from the home switch is what we're telling it dynamically when we jog around our table and tell it that we want to zero at that position. We zero, and we have just changed our offsets to reflect the distance from the home switch. And we can see that easily by pushing machine coordinates. The numbers here are identical to the numbers here, because machine coordinates is telling you the exact same information as a fixture offset. It is telling you the distance from a home switch at all times. And again, the machine coordinates are inviolable. You cannot change them except expressly referencing. The system is careful about two things in particular. One is the value of your machine coordinates. The other is the value of a DRO. The DROs are kept separate from Mach 3 in code of their own. When you see a count in a DRO, it means the system has put out that number of pulses. It's a very important debugging and troubleshooting tool for me. When someone tells me that their DRO indicates they have moved 1 inch, but they have only moved a half an inch, I know what the error must be, because I know that a DRO is always accurate. Its code is not attached to Mach 3 in any way in terms of how it changes. A DRO changes only if pulses have gone out the printer port, unless you have referenced. That is the only thing which will change a machine coordinate. So, With that having been said, I think you understand a bit more about home switches, how to activate them, when they should be active high and low, and what all of it means when you select an offset system. And remember the most important rule of all. If you set a fixture offset because you have a jig attached to your table, or you know that at 50-50 minus 20 will be the top part of a piece of material you're going to cut 1,000 times, never press the 0 buttons once you're in those fixtures. Always go back to fixture offset number 1 if you're going to jog around and do jobs at an indiscriminate point simply by hitting 0 and recutting the job. This display mode tool can be a valuable way to see where you are in a particular offset system. Here in G54, we know that we're going to cut this job at this location, and this location can be seen by checking the machine coordinates button. If we select a different offset system, G55, which we programmed to be 50-50 from the home switches, we can go back, hit Regen Toolpath, and we can see that the job is now going to be cut 50 and 50 away from the home switches. It's that simple. It does take a little while to wrap your head around this, and because of that, I'm not going to go any more complicated in this video. There are several things that you can do with offset systems. I think there's enough power in the knowledge of how machine coordinates work, how the offset systems work, and how they can use them, that I think that will do pretty much everything everyone needs to do at this point in time for homing.
Thank you for watching a CNC wood carving video. Please follow me on Facebook.